Yeah, our mandatory project.
Okay.
Pushes here.
Today we're going to go over combinatorics. Before I get started though, does anybody have any questions?
And there's no need today.
Okay. All right. So this is the quiz on combinatorics. This is the problem that gave a lot of people issues. The restaurant. Okay. Two things are going on with this, but let's go ahead and read it first. A local barbecue restaurant offers 2 side dishes with a lunch plate. There are 7 side dishes. How many choices of side dishes does a customer have? Note, there's no requirement that the customer chooses different side dishes. He or she can choose, say, baked beans twice as their side dish. In other words, a double order. Okay? Now, ignoring the double order for a minute, how many different ways can we have 2 side dishes with 7 choices? Is that a permutation or a combination?
Combination?
Combination, because it doesn't matter what order, does it?
Yep.
Okay? So we want to use the equation for combinations, which is n factorial divided by r factorial times n minus r factorial, right? Or n minus c, depending on which literature you look at, right? Where n is the total number and r is the number you're choosing at any given time, right? So, we have a total of 7, so that's 7 times 6 times 5 times 4 times 3 times 2. R is 2. And n minus r is 5 factorial, which is 5 times 4 times 3 times 2, which cancels those out. Okay? So then we have 7 times 6, which is 42, over 2, which is 21. So we have 21 possibilities with 2 different side dishes. Now, how many ways can I make a double order? How many?
A double order?
Yeah, baked beans and baked beans, coleslaw, coleslaw.
7.
7 ways, right? Because there's 7 types, right? So you add 7 and you get 28. So that's how that problem works. Does everybody see that now?
I think that one still kind of like tripped me up.
Yeah, it's that extra 7.
Yeah.
It's the double order, right? But that was just to demonstrate that combinations and permutations don't cover everything in a problem you might want to be solving, right? Okay. All right. Any questions on that one? If it shows up on the final, everybody's okay?
Oh, she has a question.
Yes.
Oh,
I'm sorry.
So the equation that you derived from that, how did you think that through? Like the ends?
Oh, yes. That's the combinations. That's the equation for combinations. This is the total number of choices, which in our case is 7, right? This is how many you're picking at a given time, which is the 2. Okay, because it's 2 side orders. And then n minus r, of course, would be 5. Okay, does that make sense? Sometimes you'll see it as n and c. Sometimes it's n and r. It depends on who the author is in the literature. Of course, we know in algebra the letters don't matter, do they? Okay. If you take away the r factorial, what do you have? You have permutations. So the equations are very similar. Right? Okay. Okay. A student club with 30 members needs to choose officers. There are 5 officer positions and no member can occupy 2 positions at the same time. How many possible slates of candidates are there? Now, the magic word there is slates, meaning that how many groups of 5 are possible. But that's before we elect who is going to be president, who's going to be vice president, and so forth, okay? So just the slates of officers. So is that combinations or permutations?
Combination?
It's combinations because we don't know what order they're in yet, do we? We don't know what position each one's going to have. So it's a combination. So again, we want to use the n factorial over r factorial n minus r factorial, okay? Well, the n is 30, isn't it? And the r is 5 at a time, and that's 5 factorial, times n minus r, with 30 minus 5 would be 25 factorial. And that would be this one right here. Why is there parentheses here? Does anybody know? This is a math question rather than a computer science question. But anyway, when you have a slash like this, you don't know as you're reading it, you know that's the numerator, but this might be the denominator, and then you're going to multiply the whole thing by 25 factorial. You don't know if that parentheses isn't there. This parentheses tells me this whole thing is the denominator. Okay? Because, and this is going to be true in programming, is the reason I pointed out, if you write this wrong in programming, you'll get a different result. If you take 10 divided by 2 times 5, what are you going to get? What's the answer?
25?
25, right. But what if you really meant that?
1.
What's the answer there?
1.
1, yeah. So when you are writing it out with a slash like this, you want to put a parentheses around it if you want that whole thing to be your denominator. So that's why that parentheses is on this one. Okay, is everybody okay with this one now? It's clearly combinations because it's just how many groups of 5 can I get out of 30, irregardless of what order they're in. Okay? Okay. Okay. Both bridge and poker are played with 52 cards. A poker hand consists of 5 cards and a bridge hand consists of 13. Are there more possible poker hands or bridge hands?
Yeah, I got that one wrong.
Mm.
But
Well, first of all, is this combinations or permutations?
combination.
Combinations, because when you get dealt a hand, it doesn't matter what order they come in. You normally arrange them in your hand maybe differently, but it doesn't matter how they come to you. So it's combinations. So our equation again is the n factorial over r factorial n minus r factorial. So for poker, we would have 52 cards. And it says that in this particular game of poker, we're going to look to do a 5 card, okay? So we want 5 factorial times 52 minus 5 is 47 factorial. For bridge, we also have 52 factorial, but now we have 13 cards dealt out, so that's 13 factorial times 52 minus 13, I believe, is 39, if I did that right. 39 factorial. Okay. Which one of those is bigger? Because the one that's bigger is the possible poker hand, or bridge hands, right?
Mm-hmm.
Well, you need a calculator for that, don't you? Now, does everybody still have their TI-84 or 83?
Yep.
I doubt if there are any 83s, right? No 83s? 84's been out long enough now. I used to have to ask that question. They're both practically the same. But anyway, if you have an 84 or an 89, you have, not only do you have factorial, but in the math menu on there, you have combinations and permutations. Okay? And the way they're normally written, the combinations may be written in this way. This one would be 52C 5, and this one would have been 52C 13. And you'll find that in the math section on your calculator. Turns out in this case the bridge hands have more possibilities. Okay. Any questions on that? It's just another one of the combination questions. Okay. So one of the license plate questions. Now this also relates to passwords when you're trying to figure the number of passwords that are possible given a particular rubric that you come up with or rule for setting passwords. So license plates in the great state of Utah consist of 7 letters and 4 digits. Both digits and letters can repeat in the order in which the digits and letters matter. Thus, AA1111 and A1A111 are different plates. All right, so this is key right here. This is important. How many possible plates are there to justify your answer? Well, first of all, if all I look at is this pattern right here, the AA1111,
God bless you.
and I go back to the bookkeeper rule, one of the ones that we studied, remember how that works. It's actually a version of combinations. You take the total number of characters, 1, 2, 3, 4, 5, 6, and you divide by the quantity of each different type. So I have 2 A's, and I have 1, 2, 3, 4 numerics, okay? And that would be the answer to how many of this particular pattern. Wait a minute, let's see. No, I'm sorry. Go back a minute. That's how many different patterns I can have. The bookkeeper rule gives me how many different patterns of this. Remember the BOOKKEEPER? Okay. So what does this come up to? Well, it turns out that 6 factorial, of course, is 6 times 5 times 4 times 3 times 2. And 2 factorial is just 2 times 4 times 3 times 2. These cancel out. So I have 30 over 2, which is 15. So there's 15 different patterns when you have 2 alphas and 4 numerics. Did I see that okay? That's just the alphas and numerics. Now, for any given one, they're going to all be the same. If I take this one, how many ways can I pick an alpha?
26?
26 ways, yeah, right. 26 letters in the alphabet. And I think they can't repeat, right? So how many ways can I pick the second one? 26. And how many ways can I pick a numeric? 10, because we count 0 through 9 is the way it works. So there's 10 times 10 times 10 times 10 times the 15 different patterns. And that would give me my total number. And that's this one right here.
So there's 15 different patterns. That includes the first 2 that they have right there?
Mm-hmm. Notice that this one is 26 times 26 times 10 times 10 times 10 times 10. This one is 26 times 10 times 26 times 10 times 10 times 10. Aren't these both the same?
Yeah.
Because multiplication can happen in any order, can't it? All right? It's using the associative and commutative laws. You can switch things around, right? So, each one of my 15 patterns, it doesn't matter where I put my alphas and numerics, the total number is going to come out the same, isn't it? And there's 15 of these. So therefore it's 15 times the 26 times 26 times 10 times 10 times 10. Okay? That was a good question, because you really want to exercise that, make sure they're the same every time, right?
Yeah.
Okay. Any questions on that one? Okay. So when you're reviewing for the final, you may want to put down in your notes to review that bookkeeper rule, because that's what that was, along with the choices. Okay. Now, like in Utah, license plates in the great state of Wisconsin consist of 2 letters and 4 digits. However, only digits can repeat. So the letters cannot repeat. And the 2 letters always precede the digits. So now we only have one pattern. All we have in Wisconsin is the letters preceding the digits. That one. But the letters cannot repeat. So how many ways can I have license plates in the state of Wisconsin?
26, 25.
26 times 25, because once you've chosen one for this one, there are only 25 left. But the numbers can repeat. So it's 26 times 25 times 10 times 10 times 10 times 10. Okay, is everybody okay with that one? Okay. Okay, an individual's chances of being killed by a lightning strike in a given year is 1 in 5 million. The Georgia Lottery has just invented a new game, Thunder, in which you win if you guess 5 out of 65 numbers right. Order does not matter. When you see order does not matter, what should you start thinking immediately?
Combination?
Combinations, exactly. So, now when I come up with a number of combinations, how do I compare it to the 1 in 5 million? Isn't it 1 out of that many is the right answer? Okay. So it's a fraction. So let's first of all figure out what 5 out of 65, how many different ways can I have 5 numbers out of 65
God bless you.
different numbers? Well, n is the 65 and 5 is the r, in case of what I've been showing you. So I want to use n factorial over r factorial n minus r factorial, which would be 65 factorial over 5 factorial times 60 factorial. Right? And when you do that on your calculator, you'll come out with something like 8 million something. Okay? But you want to put 1 over that, don't you? Because you only have 1 chance out of that many winning. So how does this number compare to that number? Which one's a bigger number? What happens when your denominator is bigger? Is your number bigger or smaller?
Smaller?
It's smaller, isn't it? This is 1 in 8 million. This is 1 in 5 million. Now, if I had said something to really make it different, there's 1 in 8 million chances of winning the lottery, but there's 50-50 chance or 1 out of 2 chances you're going to get hit by lightning. You would say, oops, hit by lightning is much higher, right? Notice the 2 is much less than 5 million. So the 1 in 5 million is more likely to happen than 1 in 8 million. Did everybody see that? So you're more likely to be hit by lightning, aren't you? Now when you work that out, it's not exactly 8 million, it's like 8.4, 8,400,000 something, I think. Okay. Is everybody okay on that one? And one more. This one requires a little bit of knowledge that comes out of statistics. There's a job in the insurance business called Actuary, which is a very high-paying job, but a very boring job, figuring out the chances of people dying from something or getting a disease, and then putting that into the monetary costs of the insurance so that the insurance company makes the margin they need to run the company. Okay, so the cost of insurance is $900 per month. The cost of an operation for a dramatic injury is $500,000. The chances of someone needing such an operation is 47.3% over a 20-year period. From a purely financial point of view, is it better for you to buy the insurance? Okay, so we're going to look at it in terms of a 20-year period because that's what we know. So if we looked at 1,000 people having the $500,000 injury in the 20 years, how would we figure out the cost to the insurance company? Well, we would say only 47.3% of those people actually had the injury, right? So we'd multiply the 500,000 times 47.3 times the number of people. Okay? So that's the way insurance companies work. So the cost of the injury is prorated, if you want to call it that, at 47.3% times 500,000. The cost of the insurance is $900 per month, so that's 900 times 12 times the 20 years. Okay. Or 900 times 24, 140, is that right? Okay. And it turns out that the insurance is a lot less expensive than the injury. Okay? So therefore, it's better to buy the insurance, right? Okay. Any questions on that? From this situation here, though, from the insurance company's point of view, it's a bad deal. They're going to lose money. So you definitely want to do that one because maybe I fixed it for the final. I can't remember. I just know this has been in the quiz for a while, and I know that it's a bad deal for the insurance company. Okay. So it's probably not indicative of real life. Okay. Any questions then on combinatorics as it's related in the quiz? Okay. So that will be on the final. Now remember that the final will be up for a week, which is what, next week? And we'll have class periods during that time. So as you run into questions, and combinatorics seems to be the area that is toughest for people. But anyway, if you do run into problems there, I'll help you in class. Okay? Because what's the purpose of the course?
To learn?
To learn, yeah. Learn. So don't panic. All right? Just work at it methodically. Make sure though, that you look at it early in the week. Don't wait till the end. So I was telling another class, I think I've seen a pattern over time, because I can see when people take the test. It shows up the date. And people who take it twice after the last class period that I go over it do worse than those who did it once to find out what they didn't know and brought those questions to class. Because there seems to be a psychological thing about if you've tried something, you've at least thought it through. And you've got some clues in your mind, and you know where you're blocked. And when you're helped with that particular block, it's kind of like an aha thing. I figured it out. I know it. I'm not going to forget it. If you go with the psychology, because I allow this with what I set up, I don't advise it, but I allow it. I'm not going to do the test, so I'll have 2 tries at the end. You really don't get the questions that are being asked during the week. And when you try it that 2 times, you say, oh, I wish I'd had a chance to ask that question. Okay? So don't do that. Because you don't do as well. Not because I don't want you to. It's because you don't do as well. Okay. So that's all I've got for today, unless there's questions. Does everybody have their project in, I hope? Okay.